Suppose you start with just the number 1 and you can do any of the arithmetic operations with it. You can add, times, subtract, divide. From there, can you build up to all of the other numbers? So what's the first thing you do? Well, 1 plus 1 is 2. Obvious. You can keep on adding 1. Definitely, you can get to every number. That's easy to say. But how quickly can you get to every other number? So have a think about that. Have a think about if there's a strategy that will get you as quickly as possible to any number that you pick. I've made a game of it, as is my want, and I'll show it to you. So it's called Number Builder. You pick how many digits you want to have in your target number. I'll pick quite a small number to start with so we get there quickly. And then start the game. So I start with the number 1, and I've got my 4 operations to choose here. So 1 plus 1 is 2. I have to get to 115, that's my target. So I think, well, 2 times 2 gets me to 4, and then 4 times 4 gets me to 16. So I can square things, really. That will get up very quickly, that will grow very quickly. But then what? 16 times 16 is 256, and I've overshot. How close do I want to get? I can divide by 2, I suppose. 128. Now I have to do a little bit of mental maths. How close am I? I think I'm 13 away. What's an efficient way of doing that? Well, I could subtract 16, I suppose, and then add on the 2 and add on the 1. And there we go, 9 moves, as opposed to 115 plus 1s, or whatever. So that's the game. So now I'll talk about some of the mathematical questions I've had while playing the game. So you might know that every number can be written in binary. What that means is it's the sum of a load of powers of 2. And we could get to powers of 2 really quickly. A guess that you might make is that, well, if I just make all of the right powers of 2 and then add those together, maybe that's the most efficient way, but I don't think it is. So there are definitely numbers, quite small numbers, that's not true for. I'll see if I can get some. So target is 14. In binary, that's 8 plus 4 plus 2. So if I make 8 and 4 and 2, so 1 plus 1 is 2, 2 times 2 is 4, 4 times 2 is 8, and then plus 4 plus 2. That's 6 moves. But what else could I have done? I could have done 1 to 2, 2 to 4, 4 to 16, and then take away 2. That would be only 5 moves. So it's a little bit quicker. What I like doing is pick a really, really big number. This is going to take me quite a while. There are a few things going on here. There's a few ways of playing this game. I might want to minimise the number of moves. I might want to just get there. I might want to just get to that target, and that's an achievement. For this really big number, I think that is an achievement. Or I might want to do it as quickly as possible in time. Now, when I was playing with the smaller numbers before, I had to do a bit of mental arithmetic. Doing it with this really big number, I can't do a precise subtraction even very quickly with something that's 16 digits long. So I'm going to have to estimate. So what are the strategies that help me do this as quickly as possible? So let's have a go at this. The game shows me all the moves that I've made. I don't really want to use these big numbers again, so I'm going to shove them down to the bottom. Don't want you anymore. Right. So I'm now 200, whatever that is, trillions, quadrillions away. So I want, Ooh, that was completely the wrong order of magnitude. Crikey. Oh, something I've encountered a lot when doing these big ones is, at some point, I feel like I want a 3, even though you can't easily divide by 3 if you're, lots of these are just sort of big powers of 2. At some point, 3 becomes useful. I want to know exactly when that is. Like, sometimes I could just, like, if I've got 4 of something and 2 of something, I can add a 4 and then a 2, which gets me 6 of that thing. Or I could, if I had a 3 all along, I could have just multiply by 3 and then by 2. 8025253. So I'm getting there, I'm getting there. Eight, 5, 1, 5, 2, 4 away. Ta-da! I did it in 57 moves. Definitely not the quickest way. I made a few mistakes along the way. But 57, it was a 16-digit number and it took me like 5 moves for a 2-digit number. How does it scale? It doesn't go linearly, definitely. Does it go logarithmically? Does the number of moves, is it in proportion to the number of digits in the target? Maybe. What does that mean? Really big numbers, I mean, they're feasible to do. It feels incredible to home in on such a big number so quickly, just starting from 1. I mean, I couldn't have written down this thing. So what that's done is that's expanded the operations I did backwards to get everything in terms of 1 at the start. So there you go. That's a way of writing down this big number. So yeah, this one's a bit of a thinker. It's not as quick draw as the prime game, but I don't know, I'm enjoying it. What do you think?